Hello, welcome to my channel. In this video, I'll be discussing quantum number and electron configuration. Quantum numbers are sets of numeric values that describe the unique quantum state of an electron in an atom. They provide information about the position, energy, and spin of electron. Simply put, we can imagine quantum number as an address of an electron in an atom. If you watch my video on atomic structure, I talk about the near model of atom in which there is nucleus containing neutron and proton and around which electron revolve. Quantum number tells us the orbitals, the location that we can find a specific electron. So it's more like an address of an electron in the orbits of an atom. There are four types of quantum number, and each of them have meaning when you write down the electron configuration of an electron. The electron configuration is the address, while the quantum number are the components of electron configuration for a specific electron in an atom. You can imagine when you are talking about address of an individual, you can mention the city, right? You talk about probably the zone, the streets, right? You talk about the you talk about the probably the house number and the flat number, right? The same way is for electron configuration, and the quantum number are the difference components of the electron configuration that will tell you where the location an electron can be found in an atom. The first of them is the principal quantum number. The principal quantum number represents, remember the Neil Bohr model of atom. The principal quantum number represents the difference principal energy level. This is n equals to 1, energy level 1. The second shell is n equals to 2. Okay. The third level is n equals to 3. So n can take the value of 1, 2, 3, etc. like that. Okay. It is called the principal quantum number and describe the principal energy level of the electron. The second number is the azimuthal quantum number. This describes the angular momentum and although also the shape of an of the shape of the orbital that contain the electron. Okay, it has a value between between 0 to n minus 1, meaning that when an electron has an energy level of 2, if n is equals to 2, the L will be equals to 0 and 1. Okay, if the energy level is equals to 3, the L will be equals to 0, 1, and 2. If the energy level is equals to 4, if the principal quantum number is equals to 4, which is the energy level, L will be equals to 0, 1, 2, and 3. So this is how it goes. Each of these numbers correspond to the different orbitals. While 0 is for s orbital, 1 is for p, 2 is for d, and 3 is for f. And each of these orbitals has their specific shape. S is spherical in shape, okay, while p has a dumbbell shape like this. D has a clover leaf shape like this, and there is another one. It's clover leaf shape. Okay. While F configuration is complex and it may not be properly represented on a two-dimensional something like this. So they have their specific shape. Okay. This azimuthal quantum number is very important, and when we are talking about the periodic table, we will see more of its importance. The third quantum number is the magnetic quantum number, and this determines the orientation of the electron. This determines the orientation, and it can take the value of its value depends on the value of the azimuthal quantum number. Recall that we say S 0 corresponds to S, 1 corresponds to P, 2 corresponds to D, and 3 corresponds to F. If L is equals to 0, ML will always be 0. Okay? If L is equals to P, the L, which is magnetic quantum number, will take a value which is equals to plus 1, 0, minus 1. Okay? If L is equals to 2, it will take value from negative 2 through negative 1, 0, through 1, and through 2. Okay? Also, if L is equals to 3, which correspond to orbital F, so the value will range from minus 3 through 0 to 3. Okay, these are the possible values of the magnetic quantum number ML, which determine the orientation of the orbit. The spin quantum number gives us the orientation of the spinning of an electron. Okay, it gives us the orientation of the spin of an electron. Let's say the spin quantum number gives us the orientation of the spinning of the electron, and the value can be either plus 1 over 2 or minus 1 over 2, depending on whether the electron is spinning up, in which it is plus 1 over 2, or it's spinning down, in which it is minus 1 over 2. Electron configuration describes the arrangement of electrons in an atom's orbitals, and it predicts an element's chemical properties, reactivity, and placement in a periodic table. So, this, like I said, its electron configuration tells us how electrons are arranged in an atom, and they are very important in determining some of the properties of atoms of elements. When you want to write the electron configuration, there are four principles and rule. There are two principles and one rule that you need to follow. Okay, the first of them is the Aufbau principle. Now we are going to apply the knowledge of the quantum number that we learned in the earlier slides in writing the electron configuration of an atom. Okay. Now, the first principle is that the electrons usually uh, fill the orbits. It fills the orbitals in the order of increasing energy level. It usually occupies the orbitals in the lower energy level before it moves to the higher energy level. Let's try to understand what this thing is saying. The energy level can be indicated like this: 1s, 2s, 3s, 4s, 5s. The next one is P: 2p, 3p, 4p, 5p. The next one is D: 3d, 4d, 5d. The next one is F: 4f, 5f. Take note of these numbers. Now, how will the electron be filled in the orbitals? The electron will be filled in such a way that it starts from the lower energy level to higher energy level. Check this arrow out. This is how it is. One S is at lower energy level than 2s. 2s is at lower energy level than 2p. 2p is at lower energy level than 3s. So this is how it goes. So you start from 1s to 2s to 2p, 3s, 3p, 4s, 3d, 4p, 4s, etc. That's how the electron will be filling the orbitals. So this Aufbau principle, that's the Aufbau principle. Start from lower energy level to higher energy level. Now, the other principle that you need to follow is that an orbital can hold a maximum of two electrons, one spinning up and the other spinning down. That's what Pauli's exclusion principle say. Otherwise, no two electrons will have the same electron configuration. Even if they occupy the same orbitals, one will be spinning up and the other will be spinning down. So Pauli's exclusion principle states that no two electron, every electron have its unique electron configuration, and no two electron will have the same electron configuration. In fact, if they are located in the same orbital, one will be spinning up and one will be spinning down, meaning that their ms will be different. Okay, and the Hund's rule states that electron field degenerates orbitals singly first with parallel spin. The degenerate orbitals are p, d, and f, while and f, while s is generates orbital. Okay, what Hund's rule is saying is that don't forget that s has only one orbital, while p has three orbital. D has one, two, three, four, five orbitals, while F has seven orbitals. Hund's rule states that when electron is filling this, if there is extra electron that's spilled to the p orbitals, it will occupy this. When the next electron comes, instead of it to fill this space, it will rather move to the next one and fill it singly before it starts filling it, before it starts doubling the electron in the orbital. That's what Hund's rule says. So when you are writing the electronic configuration, these are the principle and the rule that you need to follow. The electron configuration has several applications, and one of them is in chemical bonding. It predicts whether the chemical bonding between atoms will be covalent or ionic bonding. And also in spectroscopy, it helps understand the absorption and emission of light. And in magnetism, the electron configuration, according to the Hund's rule, that states that for degenerate orbitals should be singly filled before doubly filled. Orbitals that have single unpaired electrons are usually paramagnetic, meaning that they are magnetic. They are attracted, they are influenced by magnetic field. While those that have paired electrons, like for example, if these p orbitals have electrons that are all paired in all the orbitals, this will be diamagnetic, which means it will not be influenced by a magnetic field. Okay. When we get to periodic table, we'll see how important electron configuration is. It can tell us the location of the atom of the elements in the periodic table. Having gone through quantum numbers and electron configuration, let's now treat some questions for us to test our knowledge and reinforce what we know. Now, they ask us what's the electron configuration of oxygen? There's something I missed while discussing writing the electron configuration of the atom of an element. For you to write the electron configuration of an atom of an element, you first of all need to know the atomic number. So after knowing the atomic number, which we know here to be 8, the next thing is to apply the principles and the rules. The Aufbau's principle, the Hund's rule, and the Pauli's exclusion principle. Okay, now let's apply them. Recall we drew the different energy level like this: 1s, 2s, 3s, 4s, 2p, 3p, 4p, 3d, 4d, like this. Now let's write the electron configuration of oxygen. First of all, we go to lower energy level, and from there we move to higher energy level. This is the first lower energy level, 1s. We know that s orbital has one orbital to fill. The first two electrons will fill it, then they will move to the next, which is 2s. So this is 2s. This one also have one orbital. The next two electrons will fill it, making 4. The next electron will go to 2p. 2p. We know p orbital has 3 orbitals, and each of the electron, remaining 4 electron, they will first of all fill it singly, this making 7. So the remaining extra electron will now start doubling it. So this will be 4. Okay, so the correct answer is A. The second question: which quantum number determines the shape of an orbital? Recall that n determines the energy level, the principal quantum number determine the energy level. Azimuthal quantum number determine the angular momentum. It determines the angular momentum and also the shape of the orbital. Recall that this is represented by L, and L can be 0 up to n minus 1. If it is 0, it will be S orbital, which is spherical shape. So it determines the shape. If it is 1, it means it's P, which has dumbbell shape. So the azimuthal quantum number determines the shape, while the magnetic quantum number determines the orientation. Okay. Next question. What is the maximum number of electrons that can occupy the p subshell? The p subshell, recall that the p subshell has L equals to 1, and its ML will range from minus 1, 0 to 1, which corresponds to 3 orbitals. Okay, so they said what's the maximum number of electrons that can occupy the p shell? We know each orbital can be occupied by two electrons, each of them spinning in opposite direction with value of plus 1 over 2 or minus 1 over 2. So the p shell can, well, only 6 electrons can occupy the p shell. This is the correct answer. What's the principal quantum number for an electron in the 4D? Recall that when you are writing the electronic configuration of an atom, it is written in such a way that you start with N followed by L is to the superscript of the number of the electron in that shell, of the number of electron in that orbital. Okay, so in this one now, this represents the N, which is the principal quantum number of this electron. So the correct answer is 4B. What's the electron configuration for a neutral atom of neon? For you to know which atom the electron configuration represents, you need to look at this number of electron. Recall that we said the number of electron in my video. You can watch my video on atomic structure. We said the number of protons is equals to the number of electron, and meaning that when we know the number of electron, we can know the number of proton, and the number of proton determine the atomic number of that element. Here we are given it is 10. All right, so we are given the atomic number of neon, and we know that the electron will be 10. So you need to total this and see which one will add up to 10. I think the answer is A. I'll leave the remaining question for you to answer. You can comment in the section below whatever your answer is. Kindly note that these are typos. Okay, it's only single of them. So you can comment your answer in the section below. Please don't forget to like, subscribe, and share these videos for others to benefit. If you want me to make video on any particular topic, kindly comment in the section below. If there's any concept that you don't understand in this video, let me know so that I can make special video on it. Please like, subscribe, and share for others to benefit. Go through the question and try to answer it and comment your answer in the section below. Until I see you in my next video, take care and bye bye.